Here? Okay, great. So lucky to be presenting this to you today. Excited about the content. You don't have me to thank for it. Tom Stickle, who's here in the front row, actually wrote most of the stuff that's here. One of our senior solution architects. I've demoted him on the title slide. We'll both be available for questions at the end of this thing. But what I'm hoping to get out of the next 45 minutes is a real look through of a couple of different layers. So we know that Windows today on AWS is absolutely a first-class citizen. It's an environment that is designed and built together with the AWS resources to be deployed in an efficient way, but that doesn't necessarily answer all of the questions that you have when designing a solution. And we want to make sure that you have an approach, a process for evaluating a potential deployment, or even a deployment that you already have on AWS from a risk standpoint. What are all the different ways that you're potentially exposed? Where are the different surfaces that that you need to control and have management over? And then we'll talk through the AWS controls that exist to manage those risks. What are the different systems from Amazon that are available so that you can both manually and programmatically control access to resources, provide the controls down to downstream users, and build systems that are defended in depth. So after that, we're very happy to say that Microsoft has also added to this puzzle. They have their own tools. They have their own systems for providing defense in depth and providing advanced security. We'll talk through the controls of theirs that work together well with us, that make it easy and straightforward to build highly resilient, highly secure infrastructures. And then we'll talk through some specific examples of applications and how you defend those and how that would work. Does that all seem okay? Good stuff to talk about on topic? Yes? Fun? Okay, good. So to start, let's talk about sort of assessing risk, understanding how it is that you'd approach this process. We have a lot of customers that that have talked to us, and they have a lot of experience, sometimes decades of experience, frankly, doing this in your own data centers on premise, doing this with physical infrastructure, doing this with manually deployed software. It's important as you're designing an application, you recognize that AWS is built fundamentally out of some different building blocks. So there are several other security talks that are happening today, but I'll give sort of a quick overview of what AWS is built out of in relation to the Windows environment and how it is that represents an architecture that you're deploying Windows infrastructure on top of. So the first piece that I think everybody's familiar with, we've built distinct regions, logically independent fleets of infrastructure deployed around the globe. Inside of those regions are availability zones, which are clusters of machines physically separated for fault tolerance and high availability. Inside those clusters of machines are EC2 instances, the servers that you use to run infrastructure. On those EC2 instances, there are security groups. Those security groups construct a system for managing in VPC, ingress and egress, in standard classic, just ingress. And that stack of server infrastructure from the physical hardware all the way up to the instance that you control is a service from Amazon to you. We've built EC2 so that you get to take advantage of all of the mechanics and plumbing of building physical infrastructure without having to do all of it. So there's a part of your architecture process. I know that when I did these kinds of designs, I wanted to know who's in charge of the door locks, and what's the locking mechanism that we use, and who's handing out the physical keys to our data center, and how do we make sure that the cabling is sort of well done. Those issues, as a customer of AWS, you hand to us. That's our responsibility. We're in charge of the dirt and the pavement and the racks and the machines on the racks and the logical configuration of those machines. And that task is a piece that you get to pull out of the work in your architecture assessment to understand what it is that you've built. On the other side of that, the operating system, the applications installed in the operating system, the configuration of those applications, those are the architecture. Those are the systems that you manage, that you secure, that you configure for secure deployment. So it's important that as you observe, and when we're saying here sort of attend to your architecture, we're not talking typically about which router that you use or how many Ethernet cables go from place to place, because that stuff is abstracted by the AWS platform. What you are observing is the software applications and how they're used to interconnect and build the application you're serving. Another sort of step after that, once you've built a clear picture, almost always, I don't think you can really get that first step done if someone hasn't drawn the graph, right? How many folks have a snazzy slide that you've shown to somebody that has all the sort of lines and arrows between the boxes that are your computers? Yes, many of you have this thing. Everyone should have that thing. It's so much easier to bring new employees, to educate external partners, to work together with teams to say, this is what we did, and here's the flow of information between pieces. Really encourage everyone to draw that thing. You saw a couple examples, even in the keynote today, the Elastic Data Pipeline, where that kind of showing the way the infrastructure looks makes so much more sense to me that there's a source of data and a worker that works on it and then a target of that data, than a list of that in a spreadsheet or something. So once you've categorized and explained the architecture that you have a way to communicate that with other folks, you have a list of your stuff. Then it's important to go through and start to model threats. What are all of the different ways that someone can attack or steal from or manipulate or damage the infrastructure that you've designed? And again, when I say infrastructure, I mean these sort of software components that you've deployed. So there are all sorts of different threats, right? There are threats from the network, from a distributed denial of service attacks, or inbound packet floods, or other kinds of attacks from a network level. There are threats from inside bad actors who take your controls and your securities not seriously and make changes. There are mistakes that can happen internally. You configure something the wrong way in a way you didn't intend. There are all these different sort of classes of threats. So just like you built a list of all of the different stuff from an architecture standpoint that represents your architecture, also build a list of all of the different things that can attack that architecture. So now you have sort of both sides of the field. Then the job really is figuring out all of the different ways in that architecture on the left-hand side you can reduce the available attack surface for all of these different threats. So if you're saying, I want to make it so that attacks coming in over the web can't hurt my databases, kind of an obvious thing there. You probably don't want to open the databases networking into the web. That just seems straightforward. It doesn't really matter whether that's a Windows thing or a Linux thing. That's just a general network best practice. That's one example. There are a gazillion others. But it represents the actions that you need to take to evaluate each of the different architecture components to reduce the surface of attack. And typically what you're using in order to reduce that surface is a set of controls, a set of systems, both Microsoft tools in this case, and Amazon tools to limit and to reduce privileged access. So playing into this concept is a design pattern of least privilege, where you really want to make it so that every one of the different systems that talks to every other different system has only the rights to take the actions that are required to do it. This is basically general stuff, and I appreciate everybody sort of making it through that overview. I'm hoping the rest of it is a little more specific. So what are the controls, right? What do you get to use on AWS in order to assert this reduction of attack surface and, as a result, mitigation of potential threats? So first, probably the most important tool, very, very useful, very structured system for managing risk is virtual private cloud. How many people are deployed in VPC today? Pretty good. We're making the strong recommendation that for production environments, in a lot of cases, VPC is far and away more straightforward, more feature-rich, more sophisticated system for managing and deploying infrastructure, particularly for Windows infrastructure. So as an overview of what VPC does, how VPC works, you're looking at two basic building blocks. One, internally to the VPC context, the building block is a subnet. So different than EC2 Classic, where individual IP addresses are assigned at boot time from our large pool, and you are intermingled with other users in that IP address space. In VPC, you assert the address range that you'll use, and you create a virtual private networking, effectively, for EC2. So those subnets can either route to the internet, can route to NAT instances, which allow the translation between subnets, or to private subnets, which route to virtual private networking connections, like our virtual or our customer gateway. So VPC allows very diverse topologies. You can not only have a connection that's designed effectively to just extend maybe an on-premise or a co-located data center. So establish a VPN connection into the AWS facilities, assign a network address range in a private subnet that extends your local address range, and route traffic, all traffic, over that connection. That's one style of VPC deployment. Another style is one where you simply want the additional controls of ingress and egress, stateful as well as stateless firewalls, to build a connection to the internet. So you'd route over our internet gateway and connect using elastic IP addresses to provide connectivity. So to back up a bit, an elastic IP address is a true, real, public IP that can be assigned to any EC2 instance, whether in VPC or not. And very conveniently, that address can be moved around. So we'll talk in a little bit about some patterns that use the movement of elastic IP addresses, not only for security plans, but also for high availability. So in VPC, inside of each subnet, you receive a service called, in that subnet, a network ACL. So a network ACL is a stateless ingress and egress firewall at the subnet level. So from a structure standpoint, you can build a subnet that has a network ACL that does not permit access, say, for example, over port 80 from the internet, where you have instances in a security group contained inside the network ACL that say that they do. They are wide open to port 80 over 0.0.0/0. That network ACL, the exterior control at the subnet tier, supersedes, because it's stateless, supersedes the stateful firewall present on the security group. So imagine the separation of roles that's possible there for your developers. You give developers internally the ability to configure the security groups that allow the instances inside of AWS to communicate with each other, where you give network administrators the permission to control the network ACL, which allows them to manage true external ingress and egress, potentially to the web. That separation of roles and separation of permissions to make changes in the infrastructure is a feature of identity and access management. How many folks are using IAM today? Every single hand should be in the air, just for context. So it's the same way as saying, does every single one of your internal Active Directory users use administrator and a password as the way they log into their email? I'm hoping the answer to that is no. And what IAM does is create an abstraction for user access that allows rights-limited credentials to the AWS APIs. So, for example, you can build a user, same kind of access as they'd have either to our management console or to our APIs, that doesn't have the full range of permissions, say, to start machines or to terminate them, to change security group access, to add it or delete it, to alter the configuration for your backups, things like that. So we have a lot of pre-built policies that you can use, just like you have pre-built roles inside of Active Directory, to be able to say, I want a user who has read-only access to all of my systems, to be able to observe the state of our configuration, or to give us a report about the behavior of systems, or I have monitoring tools that want to be able to read across the configuration of our utilities. Or you can create users that have write access, that have control access to individual products from us. So you can certainly create backups into S3. You have access to write there, but no creating new Elastic MapReduce clusters, or whichever sort of product you want to subdivide that to. Those rights-limited credentials, the way I've just described it, it makes sense for your users, right? Your developers, each individual one would get their own IAM credential. That's how they log in and access tools. But also an important concept, these are API keys. They're also the right unit of abstraction to hand to your applications. So we have another system called IAM roles. So how many folks are using instance metadata or instance user data? Anybody familiar with that concept in EC2? Okay, a couple. So that's a number that should go up. In EC2, when you start an instance, we provide a local, a hypervisor accessed URL, 169.254.169.254. You can query from that URL data, one, about the instance, what instance type it is, what's the AMI that was used to construct it, when was it built, what date time. You can also pass up to 64K of data down to the instance. So we have patterns, and this is really a powerful part of how the SharePoint automation in CloudFormation was designed. Open folks have seen that sort of design, where you're passing PowerShell scripts down to your Windows servers so that when they start, they take actions at boot time and configure themselves. Build the application they're designed to build, run the application they're designed to run. Those PowerShell scripts, imagine then they can reach back and query that 169.254.169.254 address to gather information about, like say for example, you want the instance ID of the server to be its Windows, its domain name, right, or its host name. You want to set configurations of, maybe you want a health page that's built in IIS that says, this is the internal IP address of my instance, something like that. All of that data can be queried out of that instance metadata to get that information. So another new unit of that metadata then is called an IAM role. So let's imagine, for example, you're going to build a .NET application that backs up your S3, your SQL Server data backups. They want another copy of that written to Glacier. So you could build a .NET application in a very straightforward way, but you want to give that application the credentials required to write data into Glacier. Those credentials then would be an IAM credential, but think about key management at some point. You're building that .NET app, and you paste, say, the access key and secret key into the compiled version of the application. Someone who attacks your system, who opens up that credential, could certainly use those credentials to do anything if they're not rights limited. A credential that you were trying to supply to go do backups to Glacier could instead be used to build a bunch of web servers or take other kinds of actions. So by building an IAM user that has only the rights to write to Glacier and using that key, then you've limited the attack surface. You've reduced the risk of that key. Now, another part of that is if that key were to get out, there's certainly cost associated with using Glacier. You wouldn't want some random person with the key to write data into your Glacier because it costs you money to do that. So with IAM roles, we hand the key through the EC2 hypervisor system onto the hypervisor of the instance in that instance metadata piece, and we rotate it every 30 minutes. So if you lose that key, if someone were to break into your server and steal those bits, it doesn't matter. The key invalidates over the course of 30 minutes. They'll never be able to use it again, and it's issued a new key as a new variable inside of the instance. So you can query that content out at application runtime and get a fresh key that takes fresh actions that allows you to operate in a secure way without ever copying and pasting or submitting into your source control or putting into GitHub or doing whatever you're going to do with your code and making it so that others have access to that data. So very powerful tool, very much recommend the use of IAM roles to authenticate access for your applications. So Windows also has tools. Microsoft has built quite a few systems for enabling the reduction of attack surface, and they work together with our controls. So we have a lot of folks that are used to using remote desktop. I'm a remote desktop guy. Pointing and clicking in Windows is the way that I do a lot of my work there. And so when you're building an architecture, we have a lot of folks that are very concerned about RDP as an attack surface. If someone gets a username and a password to your systems, they're just 3389 away from logging into your system. So an important control there, a way to provide another layer of isolation and fault tolerance from a security standpoint, is to construct a jump box is one word that gets used to it. A bastion host is another word. Start up an EC2 instance that's your remote desktop gateway and create an encrypted linkage from your administrators, from your developers, from your on-premise workers. Make them connect in over our VPN, so now you have encryption in network transit of all of that data, and they connect over SSL to a remote desktop gateway, an instance at the edge, effectively, of our network configured to allow that kind of inbound connection, and then communicate out of band over to a separate security group that has no public internet access over 3389 to do actual remote desktop into the working machines that you want to build. That configuration allows a complete separation. You have two subnets, separate network ACLs, so there's just no network access into that outside machine except for through that internal bastion host communicating over the NAT instance. So our goal, our hope for that is that we are definitely seeing, we have, how many folks are using Trusted Advisor? This is a component of our premium support offering. So So one of the things Trusted Advisor is checking for, and I'll tell you, you should be checking for it too, is the RDP port open to 0.0.0/0. That's just not the right way to build a reduced attack surface Windows environment. So remote server administration is an important part of configuring all these different systems, but there's also a lot of updating and management and the focus on digging in around keeping the server systems once deployed up to date. So we have a pattern that we've seen a lot of customers implement where using the connections to our internet gateway and our virtual private gateway, you can build a pattern for deploying updates using DubSauce. So how many folks, I'm going to back up just a bit so you can see this picture again because it's a component we didn't spend too much time on. So right in the middle of that thing where it says NAT on the public subnet, the little orange arrow that moves from your private subnet into your public subnet is an important channel for communications. So the routing tables on either side of this, every EC2 subnet inside of VPC allows you to define the route of traffic that's used by each server. So one channel of traffic, say for example for updating Windows, you may want to not allow those private servers to reach back out over the VPN gateway, back to your data center, and out to the internet to get updates because you want to control updates and mitigate cost and make sure that you have sort of the ability to manage the update cycle. You want to do that with WSUS. So you actually want to route from your private subnet over to a public subnet where a WSUS server is running. I'll go back to the picture of that, which is here. So with that channel, by being able to move across into systems that do have internet connection without actually providing the end server internet connection, you're able to update servers, update applications, update all of the different pieces that make your system secure, all inside of the Amazon network without leaving that network, without, again, sort of exposing yourself to that attack surface. So another really important part of some of our biggest application designs, not only the sort of SharePoint automation that I described earlier, but several others, is the use of Microsoft TMG, or Threat Management Gateway. So there's been a lot of sort of discussion about the VPC system and how it uses the security group and the network ACL combination to provide a network filtration and analysis, but that's not the same as active inspection of inbound traffic. So TMG adds a lot of value in this cycle, in this system, and we have a lot of patterns that use both Amazon native services, like the Elastic Load Balancer, in combination with Microsoft native services, like Threat Management Gateway, to provide load distribution as well as load inspection to ensure that you've built a very secure system. So TMG adds this whole list of behavioral features, very important systems to ensure that not only are you defended at the Amazon layer by Amazon native protections at the network's tier, but you're also protected for the traffic that comes in and that you do allow to come through our security groups and into your applications. So TMG accepts load balancing, works great with our Elastic Load Balancers. You can have multiple of those instances. That allows you to have the high availability of that design. You certainly don't want to have the Threat Management Gateway layer, the thing that's supposed to enable the good traffic to come through, to become a bottleneck in your infrastructure. So just in the same way that you would auto-scale web servers or build large fleets of database backends to maintain performance of the front-end app tier, you can also create multiple TMG servers to distribute load and take advantage of high availability based on multiple instances. You'll also note that this design, because of the faculty of Elastic Load Balancer for distributing traffic across our availability zones, provides the capacity for high availability by multi-AZ deployment. So you'll also see that this starts to look a lot like, it seems very familiar to me, these sort of normal onion-shaped, I go from the outside and I come through these layers of inspection before I get to the sort of juicy inside. But at each of these different tiers, we've created the same network ACLs and security groups that provide defense in depth. So you get both approaches, one tiered access in through data systems, as well as separated individual deep defense controls over each of the different applications. Also, very much recommend one of the things that we've heard a lot from customers as a thing they want in Windows environments from network assessment is the ability to analyze those traffic logs. You want to be able to look through at what the incoming traffic looks like. It's one of the things that Elastic Load Balancer does not do natively. So an important addition to this pattern is having access to that for forensic analysis of inbound traffic, making sure that the folks that are coming in are supposed to be the ones coming in. So this is the sort of biggest view of that, and it's a little bit of a squint. So this is also a good opportunity to point out that all of this content is available as a large format white paper downloadable from AWS that describes defense in depth on Windows architectures. But I do want to spend some time talking through how each of the different major areas, the major attack surfaces, the major control areas, use a service either from Amazon or from Microsoft to provide the kinds of controls required to build a high-performance infrastructure. So the 3 boxes that are horizontal, one set in each of the 2 availability zones, those are Active Directory servers. So we certainly recommend, like you would do in a normal on-premise environment, a trust relationship between multiple Active Directory servers to establish redundancy. Those are present in their own security group. Those are present inside of their own subnet, which constructs their own ACL. So outside of that, you're also able to communicate to load balancer instances. There are instances protected by load balancers in public subnets, and move traffic through from there into edge servers running TMG and back to application servers like Sharepoint. So this is a part of the design of the Sharepoint architecture, the best practices for deployment of that. So this shows what it looks like when you deploy all of this infrastructure, including your Active Directory, including the TMG servers, all of that running on AWS. We have lots of customers that have looked at more complex topologies that include the connections back to on-premise data centers to the systems that you already have running or that you're in the middle of migrating off from. There's no reason that any one of the parts of this architecture can't move to and from anywhere. So we have folks that have all sorts of, they've made a giant investment in a SharePoint server and they're not ready to move from that yet. But Active Directory is something they need the high availability of cloud to provide. So they've built these topologies that span not only our AZs, but in and out of their data centers. That's where the virtual private gateway, our hardware VPN connection, provides a lot of advantage. So that VPN connection is a pair of IPsec BGP tunnels, provides a redundant connection from your environments to us. Also very important to take advantage of that double tunnel in order to provide the kind of high availability connection that things like a backend for a database or Active Directory authentication would require. Another feature there, another important part of all of this design that's not sort of listed on the slide is really the use of Active Directory federation. So if you do have an Active Directory server that's located either on-premise or in the cloud with us, and you have users that are developing applications that use AWS, you can use our simple token service to construct federation between Active Directory and the AWS API controls, or IAM controls, to build applications where your users use your real Active Directory credentials to access our consoles, to take backups, to build systems that scale in order to be able to use the different AWS native services. So back into this protected infrastructure. Another component of this that's further to the right of this screen, and I can't really scroll over to, an important ingredient in a lot of these different systems is the database servers. So we have a couple of different features there. We have released together with Microsoft a set of features around not only SQL Server running on the newly released Windows Server 2012, but also SQL Server running as a hosted managed service in relational database service. One of the advantages there is that you're able to use our API controls, those rights-limited controls, to allow only certain users to provision new databases, to affect changes in your backup schedule, to affect changes in your point-in-time restore configuration, those sorts of changes. So the SQL servers and databases that sit at the back end of these architectures are pretty powerful tools that can be protected in the same way as, say, the SharePoint instances or the .NET application servers or the IIS web servers or these other pieces. So that's the overview, and that's the sort of review of all of the basic pieces that we've built. I hope that does a good job of covering off on all of that. We have a couple of minutes left here at the end. I want to entertain as many questions as I possibly can. I know we went through